If your code becomes a nightmare every time you try to add a feature to it, you don't know something every professional developer knows. It's called software architecture. Today, I'm teaching you the foundational architectural pattern called layered architecture. So what exactly is software architecture? In simple terms, software architecture defines the rules that help you know how to split and organize your code. It helps you know what to put where and what can depend on what. This concept isn't something new in the industry. As a matter of fact, this architecture we're going to explain today, layered architecture, was first proposed by Keith Robinson in 1979. He proposed to have 3 layers in this pattern. The first one, he called it external design, or what's known today as user interface. The second one he called conceptual model, which today we call the business logic. And the third one is called internal design, which we call today data access layer. So let's say I asked you to add an API that determines a discount based on the user membership and purchase history. In the UI layer, you just add code to expose a REST API. Then this code delegates to a service in the business layer. Then in the business logic layer, this service uses 2 other services to fetch the user membership and the purchase history and then decide on the discount. But those other services used here are just interfaces, and the actual data access logic is implemented in the data access layer. So in this layer, you would actually write the SQL logic to fetch data from the database. He defined the essential principles of the pattern as follows. Number 1, the components of a system are divided into a hierarchy of layers, each responsible for a certain kind of work. Number 2, a component in one layer can request work from other components in the same layer or a lower layer, but not an upper layer. Third, communication upward must be through a reply to a request or an indirect message through some kind of a messaging system. Although now we're protecting the business logic layer and the data access layer from changes in the UI layer, for example, but we can do better in the business logic layer itself to split this layer into 2 layers. Application layer and domain layer. But what is the difference? Domain layer represents real-world business rules, things that would exist even if there was no software. As an example, a gold member gets a 10% discount. Application layer determines how those rules are executed in the system. Example, when a user clicks place order, fetch their card, apply the discount, charge the card, save the order, and send them an email. It helps keeps your core business logic independent of technical details, so your system can evolve without breaking its fundamental logic. By the way, if you want high-value tips like these straight to your inbox, join my free email list. The link is in the description below. Now let's proceed. After this point, the 3-layered architecture became n-layered architecture, and there is no strict rule on the number of layers you can have in this architecture. And this led to the evolution of 2 types of layers, open and closed. Closed layers help enforce a strict isolation of layers. Each layer can only communicate with a layer directly beneath it. So the presentation layer directly talks to the business layer, and the business layer can only talk to the persistence layer, and etc. However, there are times when being too strict creates an unnecessary complexity. Some layers need to be open, allowing to skip them when necessary. For example, suppose you add a shared service layer that provides common utility functions for string and date manipulation. These services are directly used by the business layer and not the presentation layer. Creating this shared services layer is a great idea because it centralizes cross-cutting concerns and prevents the presentation layer from accessing low-level utilities. But there's a catch. If this new services layer sits directly below the business layer, then every other request has to pass through this layer, which doesn't make sense for normal database operations. And that's where open layers come in. By making the service layer open, you allow the business layer to bypass it and directly communicate with the persistence layer when needed, while still being able to access the shared service layer if necessary. This brings us to a well-known anti-pattern in this architecture known as the Sinkhole Antipattern. It happens when data passes through multiple layers, but none of these layers actually do anything meaningful. You just have to pass through them to return some sort of data. For example, you might have a service layer method that just calls a repository and returns whatever it gets, without adding any logic, validation, or transformation. In that case, the service layer isn't adding any value. It's just an unnecessary middleman. This usually happens when teams over-apply the layered architecture and feel compelled to have 3 layers controller, service, and repository, even when there's nothing that really justifies that. Now, to decide if a layer should be open or closed, follow the 80-20 rule. So if 80% of the time you're just redundantly passing through this layer and there's no real business value, then you can make this layer open. But if 80% of the time you actually do some logic in that layer, then it's okay to accept the 20% and keep this layer as closed. Before concluding with the benefits and the next steps, I would like to pinpoint a common misconception in our field, and that is using the words unlayered and n-tier architecture interchangeably. Before the 1980s, companies used to run all their software on one giant machine, a single machine that used to do all of the processing, storage, and user interactions. But in the 1980s, things changed. Computers became cheaper and networks improved, so systems evolved into multiple layers or tiers. The client device, like a PC, handles the user interaction, what the user sees and interacts with. The application server handled the heavy lifting, the business logic and processing, and the data server stored and managed the data. That's what the n-tier architecture means. It's commonly confused with the n-layered architecture, but they are not the same. N-tier is about physical separation, how the system is deployed. N-layer is about logical separation, how the code is organized inside the application. You can have all three-layer architecture, presentation, business logic, data access, running on one machine. Or you can deploy each one on a separate tier, turning it into a three-tier architecture. The main benefit of the layered architecture is isolation. It protects the lower layers from changes in the upper layers. But this protection doesn't work both ways. If changes occurred in the data access layer, then the business logic is affected by this change. And that's the main drawback. Dependencies flow downwards, but the impact of change can still flow upwards. That's why architectural patterns such as onion architecture, hexagonal architecture, and clean architecture were introduced. It's easy to think they are completely different, but in reality they're all evolutionary patterns of the layered architecture. They all share the same core idea. Separate concerns by grouping related responsibilities into a layer. The difference is how strictly they enforce dependencies between layers and how they handle communication across them.